So here's something that probably happened to you. You asked an AI a question, it gave you a super confident, well written answer, and then later you fact checked it and it was just wrong. Like completely made up. A fake paper, a fake API, a fake person, and the AI had no idea it was lying. That's called hallucination, and today we're going to go deep into that. We'll see why it happens and not some simple explanation like AI is unpredictable and stuff, but the actual technical reason. And then we'll look at what smart engineers are actually doing to fight it. But before we talk about fixes, we need to understand what's actually going on under the hood because the reason this happens is actually kind of fascinating. Here's the core thing: a language model is not a database. It's not looking anything up. What it's doing, and all it's doing, is predicting the next most likely word or token given everything that came before it. Think of it like autocomplete on steroids. Your phone's autocomplete doesn't care whether a sentence is true, it just cares whether it sounds like something you would say. LLMs do the same thing, just at a massive scale with insane fluency. So when you ask who won the 2021 Nobel Prize in Physics, the model isn't retrieving facts. It's generating a statistically likely continuation of your sentence. Most of the time, that's accurate, but sometimes it just fills in gaps with something plausible sounding. Okay, so the model is just predicting likely text. That makes sense for most things, but here's what it gets interesting and a little scary as well. There are actually three reasons hallucinations happen, and they are all baked into how these models are trained. One, the training data has gaps. If a topic was rarely discussed on the internet, the model barely saw it, so it improvises. Two, the model was trained to sound helpful and confident. That's literally what got rewarded during RLHF, reinforcement learning from human feedback. And humans rate confident sounding answers higher. So the model learned sound certain even when you're not. Third, the model doesn't have a fact checking module. It has no way to verify its own outputs. It just generates, it doesn't know what it doesn't know. Put those three things together and you get an agent that's fluent, confident, and occasionally completely making things up. So that's the problem. Now let's talk about the solutions. And this is actually the fun part because engineers have gotten really creative about this. The first and most widely deployed fix is RAG, that is Retrieval-Augmented Generation. And the idea is beautifully simple. Instead of relying on models' training memory, you give it a retrieval system. When a question comes in, you first search a database, that is your docs, your knowledge base, the internet, and you pull in the relevant chunks of text. Then you hand those chunks to the model and say, answer the question using only this. Now the model isn't guessing from memory, it's reading. And if the answer isn't in the retrieved context, a well-tuned model will say so rather than making things up. This is how most enterprise AI systems work today. Notion AI, GitHub's Copilot's code context, most customer support bots. RAG is pretty much the industry default right now. So RAG solves a lot, but it doesn't solve everything. What about the situations where a model needs to reason, not just look things up? That's where the next approach comes in. Here's something that sounds almost too simple. If you tell the model to think step by step before answering, it hallucinates less. This is called chain of thought prompting. By forcing the model to lay out its reasoning, it self catches a lot of its own errors before committing to an answer. The reasoning process acts like a rough draft that gets reviewed before output. And there's a more powerful version of this called self consistency. That is, you run the same question multiple times with slightly different reasoning paths, and then you take the majority answer. If 7 out of 10 runs agree, that's pretty much a more reliable answer than a single pass. These techniques are huge in production systems where accuracy really matters, things like medical or legal AI tools. Okay, so prompting helps, RAG helps, but what if you could just catch hallucinations after they happen, before they reach the user? So that's the idea behind the output verification. Some systems don't rely on the model getting it right, they add a verification layer on top. After the model generates an answer, a second process checks it. This can be another model, a smaller specialized fact checking model, or a structured database lookup. The idea is every factual claim in the output gets checked against a trusted source before it ships. A variation of this is citation grounding, that is, the model is forced to cite its source for every claim, and then an automated system checks whether the claim actually appears in that source. If it doesn't, it is either flagged or it gets blocked. This is computationally expensive, which is why it's mostly used in high stakes domain. But for things like medical AI or legal AI, it's totally worth it. Now, these three are all about the system around the model, but what about the model itself? That is, can you train hallucinations out of it at the source itself? Yes, and this is where frontier labs spend a huge amount of their time. The core idea is instead of training the model to always sound confident, you train it to be calibrated. To say I don't know when it doesn't actually know, to express uncertainty instead of faking certainty. A lot of this is done through fine tuning on datasets whether the correct answer includes hedging. That is, based on X, I believe Y, but I'm not certain. And through RLHF, where human data are specifically told to penalize confident but wrong answers. You also see domain specific fine tuning, that is, taking a base model and fine tuning it on highly curated, verified data from a specific field. A medical model trained on a peer reviewed literature is going to hallucinate a lot less on medical questions than a general purpose model. So we have covered RAG, chain of thought, output verification, and training fixes. Let me wrap this up with what actually works in production and where this is all heading. Here's the honest truth: hallucination is not a solved problem. No one has fully cracked it. The best production systems combine multiple of these techniques: RAG for grounding, chain of thought for reasoning, verification layers for high stakes outputs, and better calibrated base models. The progress of the last 2 years has been real. Models say I don't know a lot more than they used to, but they still hallucinate. And for any high stakes use cases, you still need human review in the loop. The engineers who build reliable AI systems aren't the ones who trust the model blindly. They are the ones who design the systems that assume the model will be wrong sometimes and build accordingly. Anyway, that's a breakdown. If you want a deeper dive on RAG pipelines or RLHF, drop it in the comments. I'll make it. Subscribe to the channel. Thank you.